Okay, I'm going to start by talking a bit about the mock interview that I asked you to watch last time. I'm going to talk about some of the points that I think are worthwhile mentioning, and then I'm going to talk a little bit about the two questions that were asked. So first of all, sometimes the interviewers let in the student, and you can see in this case, the interviewers decided to let in the student. Sometimes it's admin behind the scenes that will let you into the interview. That's one of the reasons why it's very important that you make sure that if you're using an iPad or a phone, you take that out of the interview as well, so it doesn't get left behind when the next person comes in. It's not unusual to have an interviewer from another college. We do share interviewers between colleges, partially because we have so many people to interview, but also that it's kind of a professional development thing, seeing how other colleges are doing it. I would expect that in any interview you have, at least one of the interviewers will be from the college that you've applied to. Interviewers will not always stop you if you're going down a path which isn't going to be helpful. When Amy started her first question, she started by doing prime factorization on 100. Then what she did with it wasn't helpful. You could actually use what she did do in order to get a solution, which is why she wasn't stopped. But sometimes an interviewer will let you go down a route and try and work out for yourself that it's not going to work. But also an interviewer might say, okay, that's a brilliant idea, but I'm going to stop you. Can you think of something else? So both are fine. An interviewer will not normally let you go for a very long time down a route which isn't going to work. They're not going to let you spend 10 minutes getting nowhere. They are going to give you hints. You can make mistakes, absolutely fine. Interviewers can also make mistakes. So if an interviewer has written down 2 times 3 = 5, do not be afraid to just say, should that be 6? We will make mistakes at times just because we are talking and writing at the same time, and sometimes that's quite difficult. So don't be afraid if the interviewer has done something wrong to let them know. On the flip side, don't insist that an interviewer has done something wrong if they say they haven't. So if you say an interviewer has done something wrong and they say, no, that is actually correct, believe them at that point. It's fine to ask for clarifications. So I think at one point Amy says, do you mean this? That's absolutely fine. Questions are a lot harder when you're being interviewed. So the question on its own doesn't sound too bad. When you're being interviewed, you will have a lot of stresses going on as well. So do bear in mind that the questions that you see us doing as mock interview questions, questions that you watch on YouTube, these things are a little bit easier if you haven't got the added pressure of an interview going on as well. You might forget words. That's absolutely fine. We know that you're under pressure. We know that you might be fumbling for words. Don't worry about it. One of the key things I want to say is that we are looking for problem-solving skills. It's not a problem if you can do it straight away. So certainly with the first question, if you've already seen a method for doing it, and you can basically regurgitate that method in front of us, that doesn't tell us anything. So don't expect when you're having an interview to be able to do the question straight away, and just be a little bit cautious about watching online run-throughs of interview questions, because on an online run-through of an interview question, normally they just say, well, here's the solution. Yeah, that doesn't really teach you anything. One of the key things is to work through problems and get stuck. Interviewers might move you on. You might not feel that you've quite finished the question and some bits to tidy up. Interviewers might just say, that's great, let's move on to the next question. And that's absolutely fine. We don't necessarily want to sit there and watch you do a load of algebra to get the very final answer or something. If we can see that you know what you're doing, we want to move on and ask you something more interesting. And the absolute golden rule is always listen to what the interviewer is saying. Okay, listen to the interviewer's hints. They might not say, I'm going to give you a hint, but listen to what they're saying. and see how you can use that to help you. I'd be surprised if you had an interview where the interviewer didn't have to give you any steering at all. It is much better if you pick up on the first, maybe slightly gentle steer and use that to help you do the question, rather than having to give a really very solid hint. Okay, let's run through the couple of questions. So the first one, which is larger as n tends to infinity? 2 to the 2 to the 2 to the however many 2's to the n, or 100 to the power 100 to the power n. Now, if you were in the webinar last time, you'll know that we talked about log being an increasing function. So we can just keep taking log of both sides, and then you end up with something like 2 to the n on one side and just n on the other side. And you know 2 to the power n will be 10. If you just sat there and did that straight off, the interviewer will probably say, okay, yeah, that's fine, let's do another question. Or the interviewer might say, can you think of another way of showing it? So the thing that Amy did first, which isn't totally a daft idea, is she started by saying that 100 is 2 squared times 5 squared. So you can rewrite this one like that, which is absolutely fine. Now, what she then said is that, okay, that is bigger than, I'm not sure if she wrote down the bigger than, that is bigger than this. Oops, that should be a squared. And then she claimed that that was bigger than 2 to the 2 to the 2 to the n, because basically got 4 2's. Now, there's a little bit of a subtlety with indices here. This does not equal 2 to the 2 to the 2 to the 2 to the n. That's not the case. So I'll just do a quick example. If you consider 2 to the 2 to the 3, that is 2 to the 8, which is, if I've done this right, 256. But if you do 2, if instead you put those brackets in, this is 4 cubed, which is 64. So they're not equal. But it's an easy sort of mistake to make. And what Amy was trying to do is she's trying to bound it on powers of 2. Now, instead, what she could have done is she could have said that 100 was less than 2 to the power 7. 2 to the power 7 is 128. And that's one of the reasons why she wasn't stopped earlier while she's looking at 2 squared times 5 squared, because she could have said that 2 squared times 5 squared is the same as 2 squared times 25 is less than 2 squared times 25 is less than 2 cubed. No, it isn't. It's less than 2 to the power 5. So less than 2 squared times 2 to the power 5, which gives you 2 to the power 7. So she could have done that. Okay, so I've said 100 is less than 2 to the power 7. Let's see how we can use that. So we could say 100 to the power 100 to the power n is less than 2 to the power 7, 2 to the power 7 to the n. Now we can use the rule that x to the power a to the power b with those brackets in is x to the power a times b. But it's important that those brackets are in there. So this side is now equal to 2 to the power 7 to the power 2 power 7n. Being careful that n is now no longer an index, it's now on the level with 7. So this is equal to 2 to the power 7 times 2 to the power 7n. That is less than 2 to the power 2 cubed times 2 to the power 7n. So what I've done there is I've used the fact that 7 is less than 8. And this side is 2 to the power 2, 3 plus 7n. Okay, so I've now got some limits on 100 to the power 100 to the n, and I know it's less than this thing. Okay, so now instead I can compare 2 to the power 2 to the power 3 plus 7n, and 2 to the power 2 to the power, I'm just going to put that bit in brackets, to the power 2n. And now you can argue that, okay, 2 to the power n will eventually beat 3 plus 7n, because an exponential will beat a linear function. Therefore, this one is the bigger one. Another thing you could have done if you're given that question is you could have started by saying, okay, well, I think this one's going to win because the n is sort of higher up in the powers. And I know that powers generally beat other things. Okay, so that was a slightly different way you could have done that question. And that was the way that Amy was sort of working towards, mixed up a bit with taking logs as well. But do remember, we wouldn't expect someone to do this straight off with no help. Okay, I'm going to talk a little bit about the second question as well. I'm not actually going to run through it. First thing I'm going to note is you don't need to explain what log x looks like. If you're asked to sketch a graph log x, you can just say, okay, it looks like this. And then the interviewer might say, okay, here it looks like it's tending away from the y-axis. And you say, actually, no, the y-axis is an asymptote. I've just drawn it a bit wonky. They might ask you what that point is. If you drew it sort of more like this, they might then ask you what's happening as x tends to infinity, which I think they did in the mock interview. But you don't have to talk a lot about a fairly simple graph. We wouldn't expect you to talk about how to draw the graph y equals x squared. You can just splat it down. And if the interviewer wants to just pick up on a point where perhaps you use a graphics tablet and it's a bit hard to draw a graph, they might just say, can you just explain what's happening there? One of the things that Amy was asked was, why does log x tend to infinity? Now, she talked a bit about the fact that the gradient was always positive, and she was moved on to the next part of the question. Gradient always being positive doesn't actually mean that something tends to infinity. So always increasing does not mean it tends to infinity. So if I draw this graph here, which I'm going to say is something like -1 over x plus 1, I think that works. That thing has an asymptotic 1, so it's not tending to infinity, but it is always increasing. I've got two proofs that you can use to show that log x is always increasing. One is the easy proof. The other one is a slightly sort of sticky-like proof. Is massive overkill for the question, but it's quite fun. So my first proof. So this is log x tends to infinity. Oops. As x tends to infinity. And this is a proof by contradiction. So I'm going to assume that there exists, that symbol means there exists. I'm just using shorthand, an m such that log x is less than or equal to m for all x. So if it's not tending to infinity, there has to be a bound. There has to be an upper bound. Then, because the exponential function preserves inequalities, we can raise both sides to the power e to get x is less than or equal to e to the m for all x. So that symbol is for all, that symbol is there exists. So I've now not saved any time at all because I've written them out as well. So that then says that x has to be less than or equal to e to the power m for all x. E to the power m is just a number, it's a fixed number, it might be a really big number. Basically, we've got a contradiction there. We can pick an x which is bigger than e to the power m. So that's the easy proof. Now comes the fun proof. Okay. Hopefully you've met integral of 1 over x. If you haven't, this bit might look a bit like magic. Log x is the same as the integral from 1 to x of 1 over t dt. So notice that here, these t's kind of integrate out. That's called a dummy variable. I could call it t, I could call it u, I can call it anything I like. as long as I don't call it x. This x up here, that's our real variable. So if I take integral of 1 to x of 1 over t dt, I get log t with limits 1 and x, which is log x minus log 1. Log 1 is 0. So that's why that works. Okay, so I've got that definition. I know that 1 over t looks a bit like this. So I'm going to integrate from 1 to x. If I consider just the bit from 1 to 2, so log x is, oops, this bit here is log x, that area. So if I look at just the integral between 1 and 2, this contribution here, 1 to 2 of log x, has got to be bigger than the area of this rectangle. And this rectangle has got area 1 times log 2. That height is log 2. Okay, so I can find a lower bound for log x. I can find an integral that's smaller. This is the kind of the trick. What I'm going to do is I'm going to consider the integral from 2 to the power n to 2 to the power n plus 1. And that feels just a little bit black magic, but it's the kind of thing that you quite a few set questions do. So I'm going to look at the integral from 2 to the power n to 2 to the power n plus 1 of 1 over t dt. That is equal to, oh, sorry, not equal to, I don't care what's equal to. That is bigger than, so I'm drawing bits everywhere, 2 to the n, 2 to the n plus 1. That is bigger than this rectangle, which is equal to 2 to the n plus 1 minus 2 to the n. I don't know why I said that was log 2 before. This is a graph of 1 over t. So this height is 1 over 2 to the n plus 1. My mistake. That curve is 1 over t. I got confusing logs. So it's bigger than the area of that rectangle, where the base is that gap, which is this, and the height is that. Okay, and then this side, 2 to the power n plus 1 times 1 over 2 to the power n plus 1 is 1. 2 to the n times 1 over 2 to the n plus 1 is a half. So that's equal to a half. Okay. So what I'm going to do now is I'm going to look at log of 2 to the power n plus 1. And I'm going to look and see what happens to this as n tends to infinity. So this is equal to power to this integral. This is equal to the integral from 1 to 2, plus the integral from 2 to 4, plus the integral from 4 to 8, plus the integral from 2 to the power n to 2 to the power n plus 1. So I can split it up into that sum. And then each of these is bigger than a half. And then I think there's n plus 1 of them. Therefore, log to the 2 n plus 1 is bigger than n plus 1 over 2. And you know that this goes to infinity. Okay, so I wouldn't expect that proof, anybody to ask for that proof in an interview, but it's quite a fun little proof where if you take these sums, it works out quite nicely. Okay, so that's 20 minutes. We've gone through the mock interview questions. I'm going to give you another video to watch this week, and we'll talk about it at the start of the next session. This is the Oxford mock interview. It's a bit different in that they only look at one question, I think, but they spend a lot longer on that one question. I wanted to talk a little about different tech options. So first of all, your college should tell you what they want you to use. A lot of online interviews will use a shared whiteboard. I think every college that I've interviewed has used Zoom, but there might be a few colleges that use Teams, and there might be a few colleges that use Miro. And I'm sure there's other ones as well. I've now found Zoom Classic Whiteboard, which doesn't have this horrible scrolling in and out stuff. So I can now use that, which is great. But you might have to use the rolling one. I think Miro is a rolling whiteboard. The various tech options are using a graphics tablet or an iPad. I think there's sometimes some confusion about what a tablet is. If I just try and show you this one, this is my graphics tablet, which I've just disconnected. It's just a surface to write on. So if you're using one of these, you need to look up at the computer screen to see what you're writing. And that takes a bit of practice. But it's not too bad, you can get used to it. And it is just a case of I've got this sort of pen thing. I used to have a special glove to stop me leaning on the graphics tablet whilst I'm writing, but one of the dogs ate the glove, so I don't have that anymore. You can buy those smaller ones for about 20 to 30 pounds. If you look around, I quite like the bigger one, but then I do a lot more with the graphics tablets. So much cheaper than a train ticket to Cambridge, if you put it that way. And if you are not told what to use, I would recommend one of those. If you've got an iPad, I would not recommend buying an iPad, especially because they're quite expensive. Other brands of tablets are available. If you have an iPad, you will need to join the iPad as a separate person. If you've got one of these, it's basically just like a mouse, you just plug it in. But an iPad will have to join as a separate person, and you must be very careful to not turn your audio on. Because if you turn your audio on and you've got two devices in the same room with audio, you get feedback and it's horrible. If you're using an iPad, the big advantage of that is you actually can see what you're drawing on. So you don't need to do so much practice with that. If you're using pen and paper, I have an example somewhere, and hopefully later on we'll do another example. You need to practice holding it up at the camera, because if I want to move it that way, I sort of need to move in the opposite direction to what I am used to. And the other thing is, if you are using pen and paper, try and use a fairly thick pen. So I think you can see that green hello shows up a lot better than the paler hello. So if you're using that, use a thickish pen. I've also seen people use a mini whiteboard and a whiteboard marker, which works quite well. But as I said, practice holding it up, because it's very easy to just move it in the wrong direction. I suppose you could actually mirror your Zoom camera, which shouldn't help with that. If you're using a phone, and I'm going to try and show you how this works. When we first did online interviews, I think one of the suggested thing was to get a phone and balance it on tins of beans, looking over your work. There are a couple of issues with using a phone. One is basically trying to get it the right way round to show your work. So there's an awful lot of people who have used a phone in interviews, and basically they haven't worked out how to change the orientation. We've ended up interviewing like that because everything's on the side. Another problem with them is balancing your phone over your work can be quite tricky. Okay, so trying to use a phone has lots of issues. One is that your phone might actually decide it doesn't want to work. It's just gone completely blank on me. If you're trying to get it to spin round to show you the writing in the right orientation, I think what you've got to do is you've got to have phone on auto rotate, and then just sort of hold it up in the right sort of position and then put it over, and then it should work. But yeah, using phones I wouldn't recommend. Much better to write on bits of paper and hold it up, or to dictate. If your school has a visualizer, I've got one somewhere, but I can't open the drawer because there's a dog in the way. But if your school has a visualizer that they're happy to lend you, those tend to work much better. And I'll try and dig mine out for next time to show you what that might look like. And I might try and get my phone to work. Yeah. But a visualizer is, again, it's a bit like a mouse. You just plug it in, and that you can rotate far more easily. You can also put it in the right sort of position. So phones, I wouldn't recommend. It is possible, but it is quite tricky to get it to work. You might have interviews. So I think St. John's in the past have certainly done it where you don't have to write anything at all. You just have to talk. You can write on bits of paper beside you if you want to write something down, but that's another option. And sometimes if tech, like trying to join your dead phone, doesn't work, we might resort to dictation, which is fine, which does work. Other options, you might have flip charts behind you. So I've seen mini whiteboards. I suppose there's nothing to stop you writing on a big whiteboard. So if you just have the camera set up on to a big whiteboard, you can write on that. I think probably the best option in terms of ease of communication is the graphics tablet or the iPad, because then if you write something, I can then circle it and say, I'm not quite sure what you mean by this bit. But all of them work, and we're used to using all of them. I'm going to very briefly talk about in-person interviews, which the main thing I was going to say is that in Cambridge, it can be quite cold. There are no hills separating Cambridgeshire from Siberia. And if the wind is coming in the wrong direction, it can get quite cold. And a lot of colleges don't heat their corridors or anything. So if you're coming in person to Cambridge, I would make sure you bring some layers, just so things that you can put on and take off. We don't care really what you wear. You don't have to wear a suit or anything. Probably best not to wear your Megadeth hoodie, maybe, but even then, I don't think anyone's going to care. And if you're doing it online, basically, we're not going to even notice what you're wearing. So don't worry too much about what you're wearing. Just remember to bring some layers. Okay, what I thought we'd do this time, rather than launching into Q&A, is I was going to ask all my mentors to just talk a bit about their interview experience. So how many interviews they had, whether it's online or in person, what tech they used, and possibly anything that surprised them. And Evan, for reasons, I'm going to leave you to the end. Okay? So I'm going to start with Archie. Can you tell us a bit about your interview?
I had 2 interviews. One wide. They gave me a partial differential equation. They didn't ask me to solve it. But they explained what partial differentiation was, gave me the solution, asked me to verify it was a solution, and then asked me to explain properties of the solution. So it was like the asymptotic behavior of the function as time went to infinity and as x went to infinity. And in the second interview, I was a bit about my personal statement. I mentioned model arithmetic personal statement, so they asked me about that, and then I was asked to prove a theorem about model arithmetic for the interview.
Cool. And was it just one question on each interview, as far as you can remember?
It was one question in the model arithmetic interview. In the first one, I was given like a few very simple warm-up questions, but they were just very basic algebra.
Cool. Thank you. Christy.
So I had 2 interviews online. One was pure and one was applied. And before that, I went to this check-in session where they basically made sure I had no one else in my room and that my background was clear. And there was a student who was helping out, so it was really helpful. And so during the interview for both of them, I was given a few problems, and the interviewer had a whiteboard on the Zoom screen. So I would dictate my thoughts, and then the interviewer would write down what I said. And generally, like, if you just speak like how you would explain normally to someone, the interviewer will like understand. Like, you don't have to be super pedantic, but they will understand what you're saying. Yeah, as for specific questions, Unfortunately, I don't exactly remember, but I do remember in the applied interview, I was asked some mechanics questions. Something like if a bike has two wheels that rotate in like these directions, where does the bike go or something? But it was very interesting. And at the end of the interview, the interviewer like told me if I got something wrong, the interviewer would be like, actually, it's this because blah blah blah. So I learned something as well.
Oh, thank you. Alice.
I had two. I had a pure and an applied. And I think in the pure one there was like maybe like three or four kind of like questions. There were no like easy ones, but then I think my applied I had two, but I basically spent the entire time on one mechanics one, getting it awfully wrong. And I could kind of tell. But then obviously that means that if you do kind of spend ages on a question and can't get it, it's not the end of the world. And yeah, I did mine orally, like just spoke it.
Thank you. Shang.
So I also had two interviews. I think I had two interviewers per interview, and each interview was about 20 minutes long. I think they asked me like one big question per interviewer. And I think in my second interview, the second interviewer asked like two questions. Like the second question was like a shorter question. My interviews were on Google Jamboard, which is no longer a thing, I think. But I think if you have them online, like with Zoom or Teams, they'll have like a whiteboard, and like my interviews wrote stuff on the whiteboard, and I also just wrote on the same whiteboard. I also have a graphics tablet. I think it's the same brand, I think, model as well. Um, yeah, they are a bit weird to get used to, but like once you do get used to them, they are quite useful. Yeah.
Henry, I know it was a long time ago. Do you remember anything about your interviews?
It was ancient history. I had two, I believe. I think they were 25 minutes each. And I had two interviewers in each of the two interviews. One of them was pure, one of them was applied. In my pure one, I did, I think, like 6 questions, and they were all kind of short. There wasn't really anything with loads of meat to it. And in my applied one, I think I did 2 questions, or something like that, or two, and then like a little bit of one squeezed at the end. Yeah, it was like I was happy with some, I was less happy with others. Learned a lot. That's all there is to it.
Thank you. Josephine.
Yeah, so I had 3 interviews. They were about like 20-ish minutes each. They were all very pure, and I like applied maths, so that was great for me. And they were all online. Obviously, it was COVID, but I didn't have a tablet, so I actually just wrote on a piece of paper and like held it up for them to see, and that was absolutely fine.
So why did you have 3 interviews? Was that just how they do it? So
I think it was Zoom.
okay.
Wait, sorry, what did you say?
Why did you have 3 interviews?
Oh, I don't know. I don't know. But yeah, they like 2 of them only had one person and the other one had 2. So maybe that was why they were in separate locations.
It's quite unusual to have an interview just one.
I think one was more pastoral than
right, okay.
Yeah, it was more about like your hobbies, but they were quite maths related. Which maybe I'm showing my colours there, but yeah, it was good.
Yeah, I have heard of sometimes somebody having a slightly more pastoral interview, which turns out to end up being maths questions.
Yeah.
Yeah, we have strange ideas of what hobbies are at times. Stephanie.
Yeah, I had 2 interviews, both of them online, 2 people each, also on a graphics tablet, but like a much smaller one. Before my interviews, I had a tech check that was ran by students just to check that like my mic and camera were working. And we didn't use Teams or Zoom. We were on something called Whereby. And for the first interview, it was more purish questions, like a guided graph sketching question. And it wasn't a difficult graph. I think the thing that was surprising about it was after all the graph sketching, stuff that I'd done in preparation. The graph I was asked to sketch was a cubic in the end. And there were some other more like problem solving, like assortment of questions. And then in my second interview, I got the choice between doing a complex numbers based interview or an integration based interview. And I went with integration. And the first part of that interview was proving like standard results. And then later them guiding me to prove more general results. Yeah.
That almost feels a bit I'm showing my age here. It sounds a bit Ghostbusters-ish. You know, choose the form of the destructor. Which type of these questions you want us to inflict on you?
Yeah.
Eve.
Hi, so I also had 2 online interviews with a tech check before. I think the tech check was actually really helpful because I think I'd got something sort of not quite working properly beforehand. And again, they were sort of student run and they sort of just, calmed your nerves before you went in. Each interview was probably about anywhere between 20-25 minutes long. One was pure, one was applied. So I imagine the format was probably very similar to a lot of other people's. I can't remember the exact sort of questions we did. I know that there was one that was to do with graph sketching, but I was dictating what I was saying the graph should look like and sort of stuff about the curve and the function and whatnot, which was a little bit weird, trying to obviously explain exactly where the sort of maxima, minima, turning points, all the sort of details about the curve, maybe the asymptotes were. But like Chrissy said, you don't have to be really like banally detailed about it. If they can see you've got the idea, then they'll sort of assume that's fine. And then I think in my applied one, I think it was like a sort of differential equations, mechanics-y orbits kind of question. I don't remember the details, but I know that it was actually quite a fun question to work through. And yeah, it was definitely interesting because it wasn't something I didn't do physics, so it wasn't something I'd seen before.
Evan, there's a reason why I've left you to last, but if you tell us about your interview experience, which will be different to everyone else's, I think.
Yeah, probably. So at Trinity, they have a 10-question test that you do before your interview. So I went into a different room. So there was like 6 people all doing this test or something in the room with me. And there was like an invigilator who wasn't even a mathematician or something. I think I sat that for an hour. And then after you finish your test, they take your sheets and all of your working that you've done and they seal it. And then you are told where your interview room is and you go and walk to that. So I went over to my interview room and what you do for the rest. So it was a 45-minute interview. I had 2 interviewers and they basically talk about what you've done in the hour, as well as basically the problems that you didn't solve, and you try and go through them as well. Yeah, that was mostly it, really.
So basically, Trinity system hasn't really changed in 30 years. They did go online for a bit. So I was interviewed by Trinity as well. I did get slightly freaked out because first of all, we went into this room with lots of great big posh pictures on the walls. And I sat down and I did this test. I kept being offered tea and cake whilst I was doing it. I don't know whether they do that anymore.
I wasn't offered any tea or cake, unfortunately.
I was offered tea and cake, but I kept refusing because I didn't want tea and cake whilst I was doing that. Then at the end, I don't think my stuff was sealed up. I think I was just told to take it with me. But the invigilator was very, very quietly spoken, and he was trying to explain to me where my interview room was. And it was pitch black, and I hadn't actually visited the college before. And I had to try and find my way to Newport in the dark. Had to find C staircase. I had no idea what that meant. So normally the staircases are numbered, lettered in a going round. I don't know if it's clockwise or anti-clockwise, but that's what C staircase meant. Eventually found someone wandering around the court and asked them where was C staircase. Found it. Walked up the stairs. Bumped into 2 people standing outside the room who turned out to be my interviewers, waiting for the room to be cleared. Then went in and did the interview. The only question I can remember is one about different platonic 3D shapes and symmetries, and also the fact that if you join up the midpoints of the faces of a dodecahedron, you get an icosahedron or something like that. That's the only question I can remember. I also had a very bad cold, so I did do a lot of sneezing. So if you are applying to Trinity, it's useful if you know vaguely the layout of the college. You'll have the option of downloading a map onto your phone. I did not have a mobile phone. They weren't, well, they were a thing, but they weren't very mobile in those days. So just be prepared for that. There's lots of questions I've seen about cameras. Is there an issue about not having a camera, and can I use the camera on my iPad? One of the things that we have to do when we are doing interviewing is we have to check that you are who you say you are. And we might have to check looking at a passport or some other forms of identification. Sometimes that is done by the admin check. Sometimes that's done by the interviewers ourselves. And we do have to tick a box on the report so it's done. So we do at some point need to see you, and we might at some point need to see the room that you're in. So I know in some colleges they ask if you just spin the camera around so that we can make sure there's nobody there. So you need to have a camera of some form. In the past, sometimes when I've been doing interviews, we've just all turned, once we've done the checks, we've all turned our cameras off. Because occasionally somebody who's been interviewed has not got a very good internet connection, especially if they're doing their interview from school. And we find that turning all the cameras off means that Zoom can cope better. But you will need a camera at some point so that we can see that you are who you say you are, basically.
Someone asked if they need to bring ID to an in-person interview. Is that the case?
I've never done well, it wasn't the case when I had my interview 30 something years ago. Evan, do you have to bring ID?
I can't fully remember, but I think I might have had to, yeah.
Yeah. I think that there's much more of an assumption that people have ID nowadays. Certainly I didn't have any photographic ID when I was interviewed. My first driving license didn't have a picture on it. Nowadays, I think people are more expecting that you'll have some form of ID. So best thing to do is contact the college. So Evan, I think you're the only one here who's interviewed in person. How did you find it?
I think I liked it in person quite a lot. I think I would have found an online interview much more difficult for myself, because I think maybe you can interact a bit more humanly with people in person. Yeah, as part of actually the reason that I applied.
Some people might not want to interact humanly with other people. I might like the
That's true.
Okay, one question for the mentors, and then we'll do a bit more maths. For those of you who use the TBO problem solving booklet, I suppose first, did anyone use the TBO problem solving booklet?
Yeah, I used it.
Yeah, okay, we've got some people use it. How useful did you find it?
Shall I go?
Yeah,
be
go
honest,
on.
I found it really, really useful. It's possible actually there was a question on the booklet that came up in my interview, but I obviously can't say what that was or anything. But yeah, I found it to be really useful.
I found it useful, but I think like using the online like YouTube mock interview videos was more helpful.
And Eve, I think you had your hand up for having used it as well.
Sorry, well, you said TBO, do you mean the Stephen Sickles one?
No, I mean the it's 151 interview questions.
I can't remember whether I used that specifically. I think I may have looked through it at one point. So I wasn't. I'll put my hand up to say what's TBO. Sorry, I may have looked through it, but I'd say I'm not 100% sure. Sorry.
I think it's quite good in some ways for giving you shortish questions which you don't know how to solve immediately. But I think the solutions are a little bit, this is the way to do it, rather than talk about different ways of doing it. Okay, just going back to calculus. So we've already talked a bit about differential equations and partial differential equations, which you won't have met. You might be asked some calculus questions. A lot of the time you'll be using calculus alongside curve sketching. So things like trying to look at maximum points and this sort of thing. You could be asked integration questions, differential equations questions. You could be asked some optimization. And I'm going to give you some set questions which you might like to look at in preparation for that. You're not expected to met all the calculus in A level all in one go. You might be asked, I don't know, to differentiate sine of x squared, or you might be asked to sketch sine of x squared, and you say, okay, I'm going to try and differentiate it, and then you might stop. And I, as an interviewer, might ask you, okay, do you know the chain rule? And if you say no, then I'll probably say, okay, well, you don't know how to differentiate this yet. This is what the answer is. And we're not going to judge you for not having met the chain rule or the product rule or things like that. If you do know it, we're going to expect you to be fairly fluent in it. So I would not expect, if somebody's asked to differentiate sine x squared, I wouldn't expect, I'm going to see if I can fit this in, I wouldn't expect someone to say, okay, well, y equals sine x squared. Let u equal x squared. Then y is sine u. It's really hard to do this. Then dy by du is cos u. Du by dx is 2x, therefore dy by dx equals dy by du multiplied by du by d. I wouldn't expect you to write all that down. What I would expect if you were asked to differentiate sine x squared is for you to, it's better, is for you to say, okay, I differentiate x squared, I get 2x, and I differentiate sine, I get cos. That's the sort of thing I would expect. So if you know something, we're expecting you to be reasonably fluent in it and not spending lots of time writing out lots and lots of stuff, which isn't really necessary. We've got some calculus notes on the STEP Support Programme website. We have what we call topic notes, and it's just a little list of these are all the things you need to know. And we've also got some calculus stuff in the warm-ups in the foundation assignments, number 20 to 25. That's where we talk a bit about why the chain rule works, why the product rule works. So if you've just been told this is what the chain rule is, go use it, and you're interested to know why it works, maybe have a look at some of those assignments. There's one question I was going to do. I realised I haven't actually done any open chat yet. So if we consider 2 to the half to the power 6 and 3 to the third to the power 6, this gives me 2 cubed and 3 squared. I know that 2 cubed is less than 3 squared. So I know that 2 to the half to the power 6 is less than that. And then taking the 6th root means that 2 to the half is less than 3 to the third. Okay, that might be a sort of little warm-up question. You might be asked, what could you do to both sides? You might be asked, okay, can you tell me what is bigger, square root of 63 or 8? That's possibly a bit easy, but to get you the idea of raising things to a certain power. So that might be a warm-up question to start off with. Next part, which is bigger, pi to the e or e to the pi? So that's obviously a slightly harder question. One thing to think about is if you've been asked those two questions, do you think that they could be linked? There's probably a very good chance that they're linked. So in the first one, we found that raising to the power 6 helped us do it. In this case, it might be an idea to raise both sides to the power 1 over e pi. I'm doing lots of powers today. 1 over e pi. So then that gives me pi to the 1 over pi and e to the 1 over e. Now, there was a lot of people that suggested looking at the function y equals x to the power 1 over x. Okay, so if you think about this, okay, so we know that we know that x, we know that x cannot be 0. We've got some people saying it might go to 0, it might go to 1. If you're trying to work out roughly what it looks like, I would stick some numbers in. So we know this point is 1, 1. We've had people saying it goes to 1, goes to 0, all sorts of things. So I'm going to look at a few values down here. If I take x equals a half, I get y is a half to the power 2, which is a quarter. If I get x equals a third, y is a third to the power 3. Okay, that's 1/27. If I take x equals 1/100th, sorry, yeah, no, x equals 1/100th, I get y is 100th to the power 100, which is pretty small. So I think what's happening down here is it's tending to 0. Now, I've drawn it like that, but, you know, it could be that it's tending in on a sort of line like that. It could be tending in like that. I'm not going to discuss which options it is at the moment. I don't like the fact that that looks like it's a stationary point. If you're looking at the other end, what happens when x is really big, I'd probably do the same thing again. I'd stick some numbers in. So if x equals 10, you know, which is really big, y is 10 to the power 1 over 10. That's the square root of, that's 10th root of 10. That's a bit hard to deal with. If I take x equals 2, I get y is 2 to the power half. If I put in x equals 3, I get y equals 3 to the power third. I know this one's bigger, so I know it's got to go up somehow. As this number gets really big, I'm going to take bigger and bigger roots of it. It's actually going to tend down to 1. Oops, that's a pretty rubbish graph. Okay. So I think I'm going to have a picture a bit like that. I don't actually know, because it could have all sorts of weirdness happening in the middle. It probably doesn't, but it could do. So I'm going to do a bit of differentiation. If you have not met implicit differentiation yet, don't worry too much about it. So I'm going to let y is x to the power 1 over x. I'm going to take log y is 1 over x log x. Then I'm going to differentiate. Y by dx is differentiate. I'm using the product rule now. I've missed out the 1 over y, the chain rule. 1 over x squared log x with a negative sign plus 1 over x squared. So I basically get dy by dx is 1 minus log x times x to the power 1 over 1 minus 1 minus log x to the power 1 over x squared. We basically have a maximum when x equals e. Therefore, e to the power 1 over e is bigger than pi to the 1 over pi. So e to the pi is bigger than pi to the e. My video's back. Okay, Alice, how are you today?
Yeah, I'm good. How are you?
I'm doing all right, thank you. Okay, I'm going to ask you to think about 3 sticks, if you like. And the lengths of those 3 sticks are in arithmetic progression. So if you haven't seen that before, that means they have lengths A, AR, and AR squared. Okay. And what I want, so I want these 3 sticks to form a triangle. Yeah, sorry, I said, someone just put in chat, I meant geometric progression. Apologies. Right, I'm just going to turn chat off, even though it's respecting me. Sorry, geometric progression, A, AR, and AR squared. And I want those 3 sticks to form a triangle. And
Cool.
what I'd like you to do is I'd like you to work out what values R can take.
Okay, cool. So I know that to form a triangle, the longer side has to be shorter than the sum of the other two sides. Otherwise they can't join up. And therefore, I think to make my life easier, I might consider two cases when R is, well, when R is 1, right? That's AA and A. That's an equilateral triangle. That's all good. So therefore, I think I might consider two cases just so I know kind of which sides are bigger and which inequalities I have to solve. So we'll take R as greater than 1 first. So therefore, like the AR squared term is going to be the biggest one. So I need AR squared to be bigger or equal to AR plus A, like that. If you, you're right about the camera thing.
Yeah, I am right about the camera thing. So I'll just jot it down here. AR squared is bigger than equal to. No, hang on. Just write down.
Less than equal to. Yeah, my
okay.
bad.
Okay, AR
Yes.
squared is less than equal to A plus AR is what you just wrote down. Yeah.
Yes. And then I know that like if A is 0, it doesn't really matter. So therefore we can assume A is not 0. So divide by A. So R squared is less than equal to R plus 1. Rearrange that. R squared minus R minus 1 is less than equal to 0, which is like a positive quadratic, and therefore I'm going to find the roots, then try and find the bit in the middle of the roots. The roots, if I can remember the quadratic formula, are 1 plus or minus the square root of 1 squared plus b squared minus 4ac, that's a 4, all over 2, which is 1 plus or minus root 5 over 2. And therefore, if I draw a little graph, like down there, do you see that?
Yeah, I can see that. Brilliant. Thank you.
Then the bit in the middle, so when x is between 1, sorry, this is an r, 1 minus root 5 over 2 and 1 plus root 5 over 2. It should be, that equality should be met.
So you just said R is between 1 plus root 5 over 2 and 1 minus root 5 over 2.
Yeah.
Okay. Is that your final?
But I also think that I have some strict conditions because I did assume that r was greater than 1.
Yeah.
And clearly root 5 is greater than 1 because 1 squared is 1, which is less than 5, and therefore really that left-hand side is a bit redundant, so that should just be 1.
Okay, brilliant.
Yeah. And now I should do the other case. So when r is less than 1, we have kind of the opposite inequality, if you like, because the sides are getting smaller. So therefore we have A is less than or equal to AR plus AR squared. Again, divide by A to get 1 is less than or equal to R plus R squared. So therefore R squared plus R minus 1 is greater than or equal to 0.
Okay, let's see what you've done so far. Yep. Thank you.
Yep. And then again, I will solve that. So that's minus 1 plus or minus square root of 1 plus 4 all over 2. So it's minus 1 plus or minus root 5 over 2. We assumed that r was less than 1. I don't really think that r can be negative. I think that would be a bad thing for the sides of the triangle, in which case our upper bound is minus 1 plus root 5 over 2, which root 5 is greater than 2 because 2 squared is 4, and therefore really our upper bound's just, oh no, that's fine because you divide it by 2. Okay, yeah, so it's 1, so r is less than minus 1 plus root 5 over 2, I think is our other inequality.
Can you just hold it up? I think that's probably should be R is bigger than. So if you look at your.
Oh, yeah, sorry. Yes. If you draw the quadratic, then you want it bigger. You're right.
That was an excellent solution. I'm just going to say one thing about it, which isn't something you did wrong, but is the way that most people go wrong on this question. But what Alice did right at the start is she said she's going to split it into two cases where R is less than 1 and R is bigger than 1. What I sometimes do when I've used this question is I've said I've drawn 3 like this, and said they're AR and AR squared. And then people just kind of assume the AR squared is the bigger one. And they end up with just R is less than 1 plus root 5 over 2, that bigger equals 0. So Alice, how could you show that this was wrong?
I guess you could try and find like a counter example in the range. So like just looking at my kind of inequalities that I've got, if R is like slightly less than 1, it wouldn't work.
Pick a number between 0 and 1.
Sorry, what did you say?
Pick a number between 0 and 1.
Like if R is a half, for example.
Okay. So if R is a
Then-
half, then go on, show that doesn't work.
Let me just get a new bit of paper. So then you have a half A, and then a quarter A. And then your shorter sides are a quarter A and a half A, which add up to 3/4 of A, which is less than A, which is a problem.
Yep, brilliant. Do you really need the A?
No, you could divide through because you can scale your triangles.
So, or you know, looking at similar triangles, you could just say A equals 1, and then you have size 1, a half, and a quarter, and it's also fairly easy to see that if you've got those ones, you can't possibly make a triangle. Okay, there was something else I was going to ask, but I'm running out of time, so I'm going to stop this interview for now. Thank you very much, Alice, and I'd like Henry to appear, and I'm going to get a fresh page.
Hello, hello. Is my audio still okay? I've put one of my earphones away because they were on low charge.
That's absolutely fine. That's brilliant.
Cool.
Okay, Henry. So you're going to be dictating what I write.
Fantastic.
And I want you to think about a parabola, y equals x squared. I'll even try and draw one. And I'm going to have 2 points, which are going to go P and Q, on the parabola. And I want angle POQ to be 90 degrees.
Okay.
Okay. And what I want you to tell me is if I move those points around the parabola, what is the locus of the midpoint? So
Ooh.
after it traces.
Okay.
Can all be done with AS maths, by the way.
That's a crazy question. My lord. Okay, so I think first of all, the thing I want to think about is the like totally symmetrical case.
Okay.
So I want to find out what angle gives me 90 degrees. So I'm going to have the lines y equals x and y equals minus x, and I'll see where they hit the quadratic. And I think they're going to hit at 1, 1, and they're going to hit at minus 1, 1, which means the midpoint of those 2 points is going to be 0, 1. So that is 1 point that is on the locus. I want to also think about the degenerate cases, maybe.
Okay.
So if I take that point P and I shift it all the way down towards the origin, I believe we should still end up getting solutions for Q, but it's going to blow Q out to like the point at infinity.
Okay.
And I want to think about how much further away. Okay, it's not so clear to me whether that point is going to where that point's going to be. In which case I want to start writing things down. So I'm going to try and like parameterize this problem. I am going to talk about the coordinate on the left-hand side, and I'm going to call it minus t, t squared.
Okay.
So I think the gradient up to that point, well, the gradient from the origin to that point is going to be t squared over minus t, so minus t. And perpendicular lines are going to have the product of their gradient be -1, I believe. It's been that's been a while.
Right.
Okay. Which means I want the gradient of the other line to have 1 over t, to be 1 over t. So I want to know what point on the parabola do we have x equal y squared, but also we have y equal 1 over t x. So we have x equal to y squared, and we have y equal to 1 over t times x. I think we're gonna have. I'm eyeballing it. I should just like work it out. I think we're gonna have. Okay, no, I'm just gonna work it out. We're just gonna sub things in, and we're gonna work it out. So we have y equal 1 over t times y squared, which means we have y times 1 over ty minus 1 in brackets equals 0. I've kind of rearranged things. I've subbed. Okay. Oh, I can't see the board, but I've subbed the first equation into the second one and rearranged. So y equals 0 is like a degenerate solution that we don't like, which means y equals t is the solution that we do like, which means we're going to have y equal t, x equal to the square root of t. Does that work?
That doesn't sound quite right.
That doesn't sound quite right to me either.
Do you say you can't see the whiteboard anymore?
Yeah, I can't see anything. Well, I can see the whiteboard, but there's nothing on it. Oh. I wrote x equals y squared on the thing in front of me. That would be why I've made mistakes. Yeah. Sorry. Okay, in which case we're going to sub the other equation in. I think we're going to we should just get it the other way around. Yeah. Maybe. I'll double check. But yeah, so we have x squared equal 1 over t times x, which means I think x should be 1 over t. And because the 0 solution, again, is the one that we don't like. And y equal to 1 over t squared. This looks I'm much happier about this. Yes. Okay, so now we need to find the midpoint of minus t squared and 1 over t squared. I think that is just going to be 1 over t minus t all over 2. And sorry. No, that's going to be. Yeah, no, it is. Yeah, I'm happy with that. Sorry, I'm going mad. And 1 over t squared plus t squared all over 2. Okay, so this is like a parametric expression for the locus of points. It's not instantly clear to me what this is. So I'm going to think about. So t, we've said, is like varying between 0 and infinity. It can take all of these values. And as t varies between 0 and infinity, the thing on the left is going to vary between, so like the 1 over t minus t all over 2 coordinate is going to vary between infinity and minus infinity. But the thing on the right is going to vary between infinity and infinity. So we're going to have some locus where both kind of the y points go up to infinity, but they're going to come down and like not go down that way, which makes sense. Okay. I'm going to give you a little bit of a hint. It could be a factorization. See the whiteboard, it might be a bit tricky. I can see it. Oh, you see it, right? Okay. So if I say that 1 over t minus t is, let's think of a letter, p. Yes. Okay. I was thinking about making a sub. That's good. I was just checking that any substitution would be like bijective.
Yeah.
Okay, so if we make that substitution, then our coordinates become p/2 and something that's not p/2. So I think that thing is going to be, it's not quite difference of two squares, I don't think.
What happens if you do p
Oh, I see. If we square it, then we're just going to pick up a constant in the middle.
Yeah.
So if we take p squared, we're going to get that thing on the top, -2, which means, yeah, so we're going to have a +2 or a -2, one of those, because p squared is equal
Yeah,
to
it's +2,
that
you're
expression.
right.
-2, so that's a +2.
+2.
Cool. And that, to me, looks like the expression of a parabola somewhat.
So if instead of p/2 we had x.
If instead of p/2 we have x, exactly, then p squared over 4 becomes x. So we'll have 4x plus 2 all over 2, 4x squared plus 2 all over 2, 2x squared plus 1.
Yeah. So that midpoint. And you already had that 1 there. So the
Yep,
midpoint.
so that makes sense. That makes sense to me. Right, so we have y equals 2x squared plus 1 is going to be the equation of the locus.
There's 2 other questions that I could ask following this. So I could ask what happens to the locus of the tangents of these points. So if you imagine the tangents here, what was the locus of the point where they cross? Is a question that I could have asked. I'm not going to, but it's quite a nice answer. The other question I could ask is, what if I wanted the triangle to be equilateral? And actually, if you want the triangle to be equilateral, there's only one possibility that you can do.
Yeah, that makes sense.
Okay.
Yeah, you need symmetry, and then there's only once you have the symmetry constraint, you only have the other constraint as well.
Yeah. So that's a really good point to make, that with the equilateral, because you've got the symmetry. Yeah, that reduces it to just one case. Right. Thanks very much. I'm going to ask all my mentors to come back in. There you go. I'm going to send around some suggested resources at the end of the session again. I'm going to ask you to watch the Oxford maths demonstration video. And we're going to do a little bit of curve sketching next time, even though we've already done some. Okay, mentors, any questions that you want to talk about? Oh, one says, does audio often mean using headphones? No, it doesn't. What you can do sometimes is you can just say, don't connect to audio. On my phone, before it died, I had a button which said audio, and I can click on that and turn it off. But on a phone, if you mute it, so if you turn the volume all the way down and also turn off the microphone, that works. Somebody said, is it true that Trinity requires a graphic tablet for online interviews? They're only online interviewing overseas students. I don't know if they require a graphics tablet. Certainly when I've been interviewing, everybody who's been overseas has a graphics tablet. Well, actually, most of them have iPads. But I don't know if they require it. Contact Trinity. Neither me nor Evan will know the answer to that one. Mentors, any questions that you want to pick up on?
Some people are asking about the timeline for interviews to come out, and I would say that it depends on your college and just like, I guess, where they are when they look at your application, and it's not necessarily a bad thing if you get your interview late, or if you got it, I think I didn't get mine until maybe start of December. But then I think it just depends on the year, so don't stress. I know it's like hard, but they will come out when they come out.
Someone asked a rather unusual question that I wasn't quite sure the answer to. They were saying that if they start their first year at a different university instead of taking a gap year, and then apply to Cambridge for maths, which I'm guessing they mean also for an undergrad, will they have to resit step that year, even if they've met the required grades previously? So I mean, I said that, you know, it will vary college to college in terms of steps. Sometimes they want everyone to have taken the same exam that year. Sometimes it's okay. But I'm not quite sure what they mean by, I don't know how, you know, applying to Cambridge whilst at uni would work.
That happens sometimes. Also, sometimes people decide that actually they don't want to do engineering, they want to do maths and might reapply. Some colleges are only accepting STEP taken in the year that you apply. So even if you've already got STEP grades, you might still have to resit it. Some colleges, if you've already got STEP grades and they're not SS, they might say, well, you need to do it again, you want to get an S in at least one of them. That also sometimes happens as well. So it's possible. Depends a bit on the college. But yeah, it could happen, but we can't say yes or no. Evan, you want to talk? Yeah. Go on.
Yeah, someone was asking if I don't get an offer after my interview, but I still do very well on the step, is there a chance I get reconsideration? So I believe that is the case. There's something like that. Is that right?
It is, but it's only for certain people. So it's for people that have certain widening participation characteristics. So I'll have to have a look to see what the exact definition is. So for some people, and I will email around the link as well, there's something called the August reconsideration pool. And that is for people who were interviewed, didn't get an offer, but then did well in STEP. You still have to sit both STEP papers to be considered for that. But I will send around the link when I do the Q&A file. I'll make sure I put the link in there. Are these questions in the Q&A also going to be emailed to students? Yes, that's going to be my job tomorrow. It's going to be going through it and just adding in answers to anything that wasn't asked. And hopefully that doesn't mean we then get 10 million questions put in. Mentors, any other questions you want to pick up on?
Yeah, there's lots of college specific questions of what will interviews at X place be like. Obviously no guarantees. Obviously there are many colleges which we don't represent here currently, but they will all pretty much, maybe with some kind of variation, be like 25-minute interviews. They'll ask you a range of questions. You'll probably have two-ish examiners, like interviewers. They'll ask you questions about this difficulty, and they'll be probably between 2 and 6-ish. Like the best kind of feel you can get for what an interview is going to be like will be through these webinars. And it's like you kind of want to know everything and you want to prepare everything and you want to kind of have every kind of niche bit of knowledge. It's like I don't think that's the best way to prepare. They're all kind of, it's not what you want to hear, but they're all much of a muchness, really.
And to be honest, if you have prepared so thoroughly that you have met every question already, the interviews are just going to ramp it up until there's a question you can't do. Because we want to see you having to think about things. We don't want to see you just regurgitating the things we've already seen. Eve, do you want to pick on something?
Yes, please. There are sort of 3 or 4 very sort of similar questions that come up about basically in terms of either reapplying, applying after a gap year, or that sort of thing. So someone asked if they don't get an offer, can they still take STEP and apply again if they get the STEP results? Yes, you can. It's not guaranteed whether you'll be able to use those said STEP results. So, for example, you might need STEP for other universities. I know Warwick and Imperial tend to use them. So you can certainly still take STEP. I, for example, took math as well just as preparation, even though I wasn't going to need it. But yeah, so you're not necessarily going to be able to use those STEP results next year. But yes, you can equally take the STEP. Someone's asked if they don't do as well as they'd like to in STEP of 1 year and they reapply, does that affect their chances of getting offer this year? That's a difficult one to comment on. So personally, I kind of know where you're coming from because I actually did reapply because during the first time I sat STEP, we were having like sort of very big family issue stuff. So it was kind of not the best time to be doing exams. So I mean, personally, I can definitely tell you from personal experience, it is possible. So I very narrowly missed my step offer in year 13. So I applied again afterwards. And that was fine, got through. So I don't think you're necessarily advantage or disadvantage. Generally, they sort of expect that because you've had that extra year out to continue doing maths and preparing, that your standard is slightly higher. So that's just worth thinking about whether you want to apply to the same college, a different one, or in general, just be aware that you might be asked, you might be slightly harder this time. So that's another thing to bear in mind. And that someone said a very similar question about, will reapplicants be ad or disadvantaged if they got to a certain stage of the application process last year? I don't think so. I think generally they consider applications on a year-by-year basis. That being said, they will probably know that you did apply last year, depending on whether you applied to the same college or not. So again, same sort of answer as the previous question. Sorry, I've waffled a bit there.
Mentors, any other questions we want to desperately talk about? Or semi-desperately?
Sorry, I'm really sorry. Oh, sorry, go on, Anne. Sorry.
You go.
Oh, sorry, I suppose I had one last thing for this because you've just got a couple more questions come through on the very same thing that we just sort of said. So sorry that I keep talking. We just had a couple of people say, like, I emailed them before I applied, telling them I was a reapplicant. So would that affect me? I don't think, materially, no. They will probably know that anyway, even if you didn't necessarily state it explicitly. So I think that should be okay. And yeah, I think that was it. But yeah, sorry, go on, Josephine.
Most of them have been answered, but there's been a lot of questions about, like, should I really get going on the step prep now? Like step 3, step 2. Like, some people have been looking at some of the content for the actual, like, first year of uni. And I want to say, like, don't worry if you feel like behind in any of that or anything. I didn't look at any step 2 or step 3 until I actually got my offer. I did some step 1 before the interview, just like looked at some interesting problems online. But like, don't worry if you're not really comfortable in step 2 yet, because don't worry, you've got plenty of time.
I was rewatching James Monroe's Oxford's interview preparation webinar from last year earlier today. And one of the things he said, which is a very good point, is that the best sort of interview question is one that basically doesn't need any pre-knowledge in order to do. So don't go learning undergraduate maths or anything like that, because we won't be asking step questions that rely on that. I think it was Archie that said they had a partial differentiation question. If that had been mentioned and the person said, "Oh yes, it's partial differentiation, I've done this," the interviewer might have picked something else. So I think in that case, it's a case, let's try and teach you something new and see what you can do with it. But yeah, step 1 questions are quite nice, and I've suggested quite a few step 1 questions. The question that I asked Henry was a step 1 question from 1994. Though in the step question, it gives you more preparation. It tells you take the point P to be P squared and take the point Q to be Q squared. Whereas in the interview, I was expecting Henry to come up with some sort of parameterization by himself, which makes it a bit harder. We've had a question about step preparation support. We offer a webinar series for UK state school offer holders.
I would also, I think, give. We've done this before in webinars, but I'd give slightly contrary advice to Josephine. I think she said, if you're somebody who's really confident in STEP, then you're in a tiny minority, like a tiny minority currently, and like there's probably not much you need to worry about. But I think it's kind of good for one's kind of preparation and good for one's soul even to start little and often with STEP and kind of just like maybe see a step 2 question, try and chew through it a bit, like over a couple of days even, and then maybe reward yourself with the answer, or maybe leave it a week or something. Just the kind of earlier you can start seeing these problems and like really getting stuck with these problems, the better you'll feel when you prepare later on. So of course, I think good for you, not strictly necessary.
So next week I'm going to talk about the Oxford mock interview. Like I said, that's another staged interview, but it's a very good example of what an interview might look like. I will try. I don't think I've put it in the suggested questions, but I'll find the question that I asked Henry and email that question around to you as well. It was 94 S1 Q4, something like that. Next week we'll do a bit more on curve sketching. If anybody finds a online video about an interview question that they think it would be good for me to discuss, do please email me, and I will have a look at it. But thank you very much, and see you next time.